Alright, we're going to go ahead and get started with this lecture video on the first law of thermodynamics. This is a really critical law to understand for all of science, really. So let's dive into the definition. The first law of thermodynamics simply states that the total energy of the universe is constant. This simply means that energy is conserved during both chemical and physical processes. We also call this law the law of conservation of energy because energy is neither created nor is it destroyed during a chemical or physical process. It's just transferred from one form or another. So all chemical reactions or physical changes will result in obeying this law that we will not create nor destroy any energy during these processes. Alright? Now, when two systems come into contact with each other, the amount of energy that comes out of one system equals the amount of energy that goes into the other system. And this is really what the law of conservation, or the first law of thermodynamics, really means. That when two systems are in contact with each other, and there's a flow of heat energy out of one system and into the other system, that energy that comes out must be equal to the amount of energy absorbed by the other system, all right, to obey the law of conservation of matter. So what we're going to do is we're going to actually model this for us. You have two boxes down here, and we're going to say in our first box that this is, we're going to label this system A. And we're going to say that its temperature is 1000 Kelvin. And then the other box, we're going to say this is system B. And its temperature is going to be 298 Kelvin. So we have two systems that are in contact with each other. And you know that from the previous lecture under heat energy, that when two systems are in contact with each other and have different temperatures, meaning that they have different average kinetic energies, there's going to be a transfer of heat energy from the system that has more kinetic energy or has a higher temperature to the system that has lower kinetic energy or the lower temperature. So in this case, heat energy is going to move from system A to system B. Alright, heat here. And of course, remember, heat is abbreviated as Q into these two systems. Now, system A, since it's losing heat, it must have a decrease in energy overall, and system B, because it's gaining energy, must have an equal increase in energy. Now, the two systems that are in contact with each other, A and B, are going to eventually come to a point where both systems have equal amounts of average kinetic energy, and then we will, at that point, we will have the same amount of, or the temperature will be the same at that point, okay? Now, the amount of heat energy that system A lost. Remember, if a system loses energy, then we give it a negative sign. So that the amount, that total amount, or the magnitude of heat energy lost by system A must equal the amount of energy gained by system B to obey the law of first law of conservation, or first law of thermodynamics, or law of conservation of energy. All right? Now, let's take a look at this in a real life situation here. So here we got a diagram of a beaker, that is sitting on top of this stand being heated up by a Bunsen burner. Now obviously the Bunsen burner, if we look at it as a system and the beaker as another system, and we're going to say that and it even says this, that the beaker contains water in it, okay, a certain amount of water. And so that water is going to be our system. And so because the Bunsen burner has definitely more energy than the water does, there's going to be a transfer of energy from flame into the water. And this is going to occur until and the amount of energy essentially that's going from the Bunsen burner to the water is going to be equal to each other. So the Bunsen burner would be negative Q, and that's going to equal to, actually probably should do this. Okay, so negative Q, which is from the burner, because it's losing energy, is going to be equal to the amount of energy that's going into the water, which is going to be a positive Q. Alright? So, as much as the Bunsen burner loses energy, that energy should ideally go into the water. Alright? So, that's the first law of conservation of energy. Make sure that you understand this law very, very well. Just the biggest thing to understand is that energy is conserved. We don't create it, we don't destroy it, and that when two systems are exchanging energy, that the energy transfer and the energy that's absorbed must be equal to each other. Alright? So that is it for this lecture.